Dear students, welcome to all. Now we will discuss the concept of Friis transmission equation. What this Friis transmission equation is telling means it gives the power received by an antenna from the another antenna. Okay, it gives the power received by an antenna from another antenna. Means that is we are transmitting a known amount of power at a particular distance. At particular distance, how much amount of power is received, that we need to calculate by using the Friis transmission equation. So for this, consider two antennas: transmitting antenna, receiving antenna. Transmitter side you will be having gain and power. This we are calling it as transmitter gain, transmitter power. Whereas in receiving side also will be having gain and power, receiver gain and receiver power. Okay, the both antennas must be separated by a distance with r. R should be always greater than 2d square by lambda. Okay, from the field regions of the antenna. This is the condition for the far field region. Okay, we need to maintain whenever r is greater than 2d square by lambda, then only the perfect radiation will be occurred in the receiver side. Okay, so finally the formula for the Friis transmission is PR is equal to PT into GT into GR into lambda square by 4 pi r whole square. Okay, how this formula is obtained, we will go to the derivation part. Okay, for derivation part, consider the first one, power density. Okay, what is the formula for power density? Here the power density is represented as small p. It is the total radiated power divided by surface area. Okay, we already know that surface area is equal to 4 pi r square. So in surface area, if you substitute 4 pi r square, you will be getting the equation 1. So power density is defined as total radiated power divided by surface area. Okay, surface area is denoted as 4 pi r square. We have got the equation 1. Next, consider the transmitting antenna has gain GT. So the transmitting antenna, here we are having the GT now. So include this GT also in the equation 1. That's it. You will be getting the equation 2. Small p is equal to PT into GT divided by 4 pi r square. Next, assume that receiving antenna has effective aperture of AE. Then the received power by the receiving antenna PR. So what the PR is telling, if you multiply the power density into effective aperture, you will be getting the received power. Okay, whereas we already know that effective aperture is given as lambda square by 4 pi into GR. Okay, so here effective aperture will be always at the receiver side. That's why here you need to take the gain at the receiver, GR. Okay, if you substitute small p, that is equation 2 here, and effective aperture area formula here, if you rearrange this equation, finally the total power received at the receiver antenna is PT into GT into GR into lambda square by 4 pi r whole square. This is the Friis transmission equation. This is very important in the calculation of the next topic, that is measurement of gain. By using this equation, we will explain the concept of measurement of gain. I hope you all of you understand. Thank you so much.